Welcome to Learning IoT. Learning IoT with Python and Raspberry Pi provides the reader with a solid foundation in the Python programming language and instructs the reader on how to write Internet of Things applications. Python is one of the most popular programming languages in the world, and the Raspberry Pi is a small and inexpensive computer. The Raspberry Pi has 40 general-purpose input-output pins. What that means is that you can connect electronic circuits to the Raspberry Pi and control the circuits using Python scripts. The Raspberry Pi also has built-in Wi-Fi capability, and this is what makes the Raspberry Pi a true Internet of Things device. What's so intriguing about the Raspberry Pi is that it enables a student to build and control useful electronic circuits. If you've taken general physics labs or a physical electronics lab, you learned how to measure the voltage across and the current through components in basic circuits. However, it is likely that you never actually built a circuit that did something useful. A piezo buzzer circuit and an LED circuit are used to introduce the reader to controlling electronic circuits using Python script. Next, the light level is gauged using a light-dependent resistor circuit. The first IoT project is to send a text message if the light level falls below a certain threshold. Another IoT project is to send an email if motion is detected using a passive infrared sensor circuit. And there's a project whereby a photo is snapped if motion is detected. Another IoT project involves using an ultrasonic sensor in a proximity alert circuit and making a phone call if an object gets too close to the sensor. A GPS hat is used to read in and store GPS data. An analog to digital converter chip is used to read in data from a light-dependent resistor circuit and data from a gas sensor circuit. A servo motor is used to rotate a camera. The final project involves building a robot driven by a quadruple half-H driver chip and controlling it using a multi-threaded application. In addition, an explanation of how to use SSH and VNC to remotely control the Raspberry Pi is included. Learning IoT with Python and Raspberry Pi provides a student with a solid foundation in the Python programming language. Every Python object has a type, a value, and an identity. The first four data types described represent strings, floating point numbers, integers, and Boolean values. Conditional statements are used to implement flow control. While and for statements are used to loop over blocks of code. Programs are made more manageable using functions. Breaking code into functions also makes that code reusable. Lists and tuples are used to store sequences of data. A dictionary is used to store data that can be accessed by a key. And the set type is used to do such things as take a union of two sets and take the intersection of two sets. Code listings that make use of try-except statements are used throughout the text, so the student learns how to handle runtime errors. At the end of the chapter on conditional statements are several circuit projects, one of which involves sending a text message if the light level detected by a light-dependent resistor circuit falls below a certain threshold. A conditional statement is used to send the text message if the condition that the light level is below a certain threshold is true. At the end of the chapter on loops are several circuit projects, one of which involves sending an email if a passive infrared sensor circuit detects motion. A while loop is used to continually monitor the data read in from the passive infrared sensor circuit. When motion is detected, the email is sent. The Python scripts that control the circuits make use of the Python syntax or the Python data type explained in the chapter in which a circuit project appears. So these circuit projects also serve to elucidate Python programming concepts. Because applications that interact with IoT devices might store data in a database, we've included a chapter on SQL for database access. SQL stands for Structured Query Language. All the code listings and HTML listings in the Web Access chapter have been included in order to familiarize the student with the tools needed to create and deploy a home monitor system in the cloud. There's a section on HTML tags, a section on how to install and configure a web server, a section on how to write Python server-side script. The home monitor project is composed of a client-side Python script that snaps a picture if motion is detected. It then uploads the picture to a server in the cloud. A Python script running on a server in the cloud copies the picture into a database, and Python server-side scripts enable access to the pictures over a web browser. The last two chapters in Learning IoT with Python and Raspberry Pi have to do with writing classes and writing multi-threaded applications. These are more advanced topics and are usually not covered in depth, if at all, in introductory Python programming courses. However, we believe it is very important to include classes and threads because the student will be well equipped to begin developing robust applications. Numerous code listings illustrate what object-oriented programming means. This chapter concludes with a project that illustrates how to write a class to control a servo motor. By using threads, a single Python script can play music and display images at the same time. Without threads, the music would have to finish playing before the images could be displayed, or vice versa. There are examples that illustrate what race conditions and deadlocking are. There's a version of the producer-consumer problem, which is a classic computer science problem. This chapter concludes with the robot project. We've included detailed instructions for assembling a robot that is driven by a quadruple half-H driver chip. We use threaded classes so that the robot can be controlled from the keyboard. We've included Penix A for those students who would like to learn some elementary circuit analysis and who would like to learn how to measure voltage, current, and resistance using a multimeter. Appendix B contains a list of components and hats necessary to do the projects described in this book.